Hello. Let's start the presentation. The fifth presentation content of Team 3 is a review of the last presentation. Architecture overview of Roof Abu Dhabi, structure, material, and preview of the next presentation. Last week, we examined the foundation construction process of the Roof Abu Dhabi, and now we're going to review it briefly. First, they create revetment to retain temporary platform by placing 15.3 meter high rock and a bank made of sand, preventing the inflow of seawater. And then they used imported fill to displace water and create platform. Concrete piles were driven, which is made by the MIP method at this beginning stage. This concrete pile was inserted in shape interlocked with the bedrock of the island. This MIP method was selected for the piling, which is suitable for the sandy and gravel layers of the Saadiyat Island. This pile was used to protect the structure from the sea by building a hydraulic cut-off wall. Before basement area's excavation, a pump was installed and dewatering in order to make the land dry. Then, 53,000 cubic meters of sand were removed from about 24,000 square meters of land. After basement area excavation, finally concrete piling began to build a basement floor. Concrete piles and steel piles were embedded on the land. After all the foundation piles were built on the excavated land, reinforced concrete loft slabs began to be constructed from 7 meters under the ground. The 25-meter foundation pile, which first supported the building during construction, served as an anchor, so that the building was surrounded by water with a tension piling to keep it from floating away and to hold it in place. Basically, that was how the foundation construction work was carried out. Now, everything is ready to build basement museum on the site.
Last parts. After completing the pile work, the reinforced concrete raft slab was constructed at a height of -7 meters, and then fixed inner and outer surface cladding layers. The next step was to install a support tower to support the dome. Additionally, a reinforced concrete raft slab was constructed at a height of -3.5 meters. After that, a dome was installed and a rim segment was constructed. Finally, various buildings were completed, including plaza and gallery facilities inside and outside the dome.
Next, we will look at the structural forms and characteristics of each building when it is divided into ground and underground floors. First, the whole basement. Slabs designed in the basement vary in height for each building. Among these different buildings, the special space underground is the second base floor. P2 is a space where artworks and logistics are transported and stored. All items are transported through this tunnel. Abu Dhabi also paid special attention to the transportation of artworks, as it aims to establish the Saadiyat Cultural District. Thus, a logistics transportation tunnel was created that considered temperature, stability, humidity, and etc. The tunnel is 12 meters wide, 6 meters deep, and 1.2 kilometers long, and is still used stably today. The second basement floor where this tunnel is connected is rigid, and the outer wall is in direct contact with water. It is 8.075 meter deep and 7.075 meter to the upper slab. The thickness of concrete is 1 meter, and the exterior wall is designed with UHPC. Finally, the ground floor plan. Visitors walk through 55 buildings, just as they wander through the narrow streets of Medina Arabia. The purpose and movement of each building are as follows. Follow the main entrances and checkpoints below, and enter the Louvre Abu Dhabi. You can enjoy the works in 23 permanent galleries. In this space, of course, there are 4 vestibules and 15 passages between the buildings, so you can take a look at the outside and relax in the middle. Then, there is the square, and in the center are a temporary exhibition, children museum, collection treatment, restaurant, cafeteria, and auditorium. Finally, I will explain the materials and characteristics of these 55 buildings. Now, I will explain the materials of the Louvre Museum inside Abu Dhabi. First, the United Arab Emirates revised its seismic design standards in 2013 after 4 earthquakes in 3 years. Abu Dhabi is located in Zone A and must be designed to withstand up to 5.5 on the Richter magnitude scale. In addition, considering the building classifications under the National Construction Code, it was classified as Class 5 because it was a museum, so designed with consideration of the building. To meet these requirements, the Louvre Museum used a highly customized raised access floor certified as earthquake resistant on the floor of 20,000 square meters. Components of this structure include the BPC structure and the Ampere structure. BPC is substructure with extra heavy stringers. Ampere is substructure with light stringers. Panels made of marble were located on these substructures. The biggest challenge for installing these marbles is that the museum is divided into wet areas and dry areas. The marble slabs had to be installed on a variety of complex substrates. Some areas are prone to major deformation, while others have to install marble stone on water-soaking surfaces. To meet these requirements, experts used Carflex Maxis 1 cement white adhesive, Carpoy adhesive, and epoxy adhesive. In response to these various environments, successful floor construction was performed while using various chemicals. The next thing I'm going to explain is the wall of the building. The walls of the building consist of 3,900 UHPC panels. UHPC is an ultra-high performance concrete with compressive strength of more than 6 times that of normal concrete. Also, the tensile strength is more than 10 times greater. This is also related to the durability of concrete and has a life expectancy of more than 100 years. In addition, the location of the building in Louvre Abu Dhabi is on the sea. Therefore, ultra-high performance concrete with smaller buoys than regular concrete can be used to prevent moisture penetration. These UHPC panels were used directly as exterior cladding to create white walls in the building. These white walls not only protect the museum from the effects of waves, but also allow it to bend outward. This is to resist when the water pressure that falls rapidly due to the tide coming and tide go out causes a suction effect. Thus, the Louvre Abu Dhabi created structurally stable white buildings.
So far, we have looked into the process of building the Louvre Abu Dhabi. A total of 119 temporary towers were built to support the dome during the construction of the Louvre Abu Dhabi. Next time, we will talk about the towers that support the dome in detail. In addition, we would like to introduce the dome like the mascot of Louvre Abu Dhabi.